Welcome to the class Matrix Basics of CAM Manufacturing and Quality Control. In the Matrix workflow, we are now at CAM Manufacturing. So this can be done at chairside possibilities at the dentist's office itself and in laboratories or milling center. So let me give you some basics of the matrix implant connection. So here you can see a random implant connection. This is a typical hexagon connection, and the reason why it is complicated to mill with a milling machine, for example, these hexagons is shown on this little video. So when a round drill is drilling this connection, you always have these little corners which are not milled perfectly. So this is the reason why we at TRI decided to change completely the inner connection of our implant system in combination with all the know-how of CAD and CAM technologies. So that's why our matrix connection looks like this. You can see on this picture we have a really round surface. We have only one rotational lock here on this side implemented in this connection, and that's why it's the world's first digital implant, absolutely possible to mill with any random milling machine in a perfect fit. And so when you see the prosthetic on this picture designed for the digital workflow, you can see here this is a typical round drill which every milling machine has implemented. This round drill can be used for milling the connection absolutely perfectly. So you can see easily possible to mill this connection in a perfect fit. And also the rotational lock can be done really accurately by a good class milling machine. Milling strategies developed for high precision. So why it is necessary that you as a milling center or a dental laboratory have to go through this class here is we need to give you the understanding of these so-called milling strategies, which you have to implement in your software later on in this training here. And the milling strategies I would like to explain you here a little bit more detailed. So the drill follows a defined strategy. So normally an STL file gets implemented in the CAM software, and then the software mills this STL file, this three-dimensional STL file. But here, for this connection of the matrix, we created a so-called matrix milling strategy, and you see this strategy here, these yellow lines is what the round drill has to follow. And when the round drill follows in circles in the connecting in the connection where it's going to be going into the implant, we are able, due to these milling strategies, to have a surface of 0.02 millimeters fine milling, and this looks like this when it's milled and sintered. For example, a zirconia connection here, you can see on this picture, this is already a huge zoom into this connection, and I think it already shows how accurately this is milled due to these milling strategies. If you zoom more into, let's say, this part here, you can see here these small lines, and this is a surface which is absolutely fantastic. Here you can see on this video how this is working. So the drill is following, the tool is following the dedicated milling strategy to achieve high precision. So you see the tool is really following exactly and accurately this given milling strategy, and that's why it's possible to have, in combination with this matrix design which we designed for CAD/CAM technologies, That's why it's possible to have this absolutely perfect fitting. So the milling strategies include high defined connection and screw seat files. So it's not only about the inner connection here, it's also inside the screw seat has to be also in a perfect fit, because we developed also special screws for any material you use. You have a different prosthetic screw to use, and that's why this connection and the inner connection is done by the so-called milling strategies. So you see here more or less an STL file, an output file of an Exocad or a 3Shape software, and what the milling strategy is doing. So we have for the different screws and for the different platforms we have in the matrix implant connection. We have the platform 3.7 and platform 4.5. We have designed these milling strategies, which the CAM software has always to add onto a STL file, like this output file of this single crown here. So let me show you how this looks. So in this crown you can see this is the connecting. This is normally STL files. This is always triangles, and what the software has to do before starting to mill is to adapt these milling strategies, and then we can mill in this perfect connection. This is just a picture what you can reach with your milling machines. This is a classic portfolio from the TRI, a classic prosthetic. You can see here the 45 degrees shoulder of our hexagon connection. This is the hexagon strongly zoomed, and you can see here these lines. This is done in titanium. This is the quality of TRI, and this is the quality you can reach in combination with the TRI matrix milling strategies when we implemented these strategies into your system. Then you are able to mill an accurate connection of the matrix connection, like you can see here on this picture. So the milling machine requirements are like followed. You have in the CAD and CAM technology, you have, especially CAM technology, you have 3x, 4x and 5x milling machines. And with the matrix is possible to mill even with a very small 3x milling machine, single crowns, but I think we focus more on 4 and 5x milling machines. You can see here with a 5x milling machine you can bridge over 2 implants. It's not a problem. You can also mill full arches in strong angulated placed implants with these machines. And just to explain you quickly what it means, a 3x or 4x or 5x milling machine, you can see this here. You have 3 axes. This is more or less forward, backward, right and left, and up and down, and this is the object to mill. With a 4x machine you have these three axes, plus you can turn the object which you have to mill around the X. And with a 5x milling machine you can have a fifth X, you can turn it around the X, and also you in a hemispheric turn. So this is 5 movements you can do, and in this moment your machine is able to mill in any direction, in any angulation, and that's why this is called 5x milling machines. And to continue with the materials compatibility, it is important that we separate the machines between chairside milling machines with 4 axes, and then there are the medium milling machines, which are mainly in dental laboratories, 4 to 5 axes, and large size milling machines, they are mostly in big milling centers. And so for the titanium, for example, it's just important that you have 860 megapascal or higher of material. Zirconia, the same thing. Everything what goes into the matrix connection has to be, and the screw seat as well, has to be higher than 1100 megapascal. This is the material your machine has to mill. And again, you can see here with large size milling machines, you can mill any indication in the mouth possible. So also here with the 4 to 5x milling machines, it's mostly a special machine which mills you the titanium, and the other possibilities are all given. Okay, this is the machine what you need. Your machine has to know how what your machine can do, and for matrix milling itself, you have to make sure that your machine either is an open system or a closed system. For example, we work closely together with Amann Girrbach and also with Zirkonzahn. So this is companies, they offer a milling machine which is more or less a closed system. So they have their own software in this system, and there the matrix milling strategies are already included. So if you work with Zirkonzahn or Amann Girrbach machines, the software is already included in with the matrix milling strategies. So from this point, you can mill in this perfect fit as I just described it already. In just by using a system like Amann Girrbach or Zirkonzahn. And then there is all open systems. So there's a lot of milling machines in the market, different companies. I don't want to name them. It's so many different companies. There it's just important that it's a 4 or 5x milling machine. And then these milling machines have different softwares, CAM softwares. And for example, Hyperdent or WorkNC, this is CAM softwares these milling machines work with. And for all these softwares, you can see here, TRI already designed the update for these milling strategies. So if you work with an open system and your machine is working with one of these softwares, then we are able to give you, after you are certificate or after you've passed this class here, you are able and ready to get the datas, the zip files downloaded, and to install the software, the milling strategies into your software. The next thing what is important is some tools. So all the milling machines have a standard round till included. For the milling the matrix perfectly, we need to have also the flat drill installed into your milling machine. So it's necessary that you always have a 1.4 or 1.5 millimeter flat drill included into your milling system or into your milling machine. And for angulated screw channel, there's a special tool necessary. This is the so-called T-tool. And the T-tool is, you can order through TRI. So the T-tool, and this is what I would like to show you on the next slide, the T-tool is an important tool because we do not have any tie base with a prefabricated screw seat in this matrix system. You have to mill the screw base with these milling strategies. And in the case you have an angulated situation, you need to drill this screw base from the bottom. So your machine will go inside here and then goes eccentrically in a circle here around, and then you have created a screw base, and that's why you need this T-tool to work with angulated screw channel. This is important to remember. So here's a little video how that works. So it's moving out of the X, and that's why you can create this screw base down here perfectly. Okay, so this is more or less the basics you need to have before we continue with the matrix CAM prosthetic manufacturing. So that you are able to manufacture matrix prosthetics in your milling machine. It's necessary that you have first of all a matrix milling strategies installed. So we have to make sure that the strategies are installed in your system. quality of milled test grounds proved by TRI. So the workflow is we make sure that your milling system is working with these milling machines, and so we help, or you can install these milling strategies, and you get all the explanations in the following trainings here on the platform, on the TRI Academy digital platform. And then when you start milling, TRI is going to send you test files which you have to mill, and then send them back to TRI, and we do a quality control of your milled prosthetics in different materials. And when we are giving you the go, then you are approved and certified milling center. This is then happening when after we proved the quality of your milled prosthetic. Okay, so if this is the case, it's working like this. The machine preparation, so you have a certificated, calibrated CAM machine, and and when this CAM machine, you have to feed the CAM software with the CAD file and construct information, the construction information. So you not only send the STL file, you also have always to send with this with the designed CAD design, you have to implement always the construction information of your to milled, for example, single crown. Make sure CAD file is correctly aligned with milling strategy. So you get this into your software, and then you need to control if these milling strategies, what we saw before, are exactly aligned and perfectly in position. All this you can read through the CAM manuals, excuse me, which you will get later on in the download area, and also will be explained by my colleague Rafael Perez later on, which explains you exactly the manuals, how this works to install, and how we do that with the milling strategies in these softwares. So okay, next step, when you have everything, when you have feeded your CAM software, please then just choose the right material, place it after standard ways, your blank into the machine, and then close the door and let the machine do its magic. You can see here on this picture, this is the matrix connection, and the strategy is following the certain lines which we already talked about to reach more or less this high precision. Here you can see a 3-unit bridge, milled, not sintered, and just like out of the machine. It's very important that you use always a cleaning thing. So just start with cleaning directly on the machine. Clean the surface, the connection of the matrix, and also the screw base of the matrix connection. Take away all the dust of zirconia. Afterwards you can clean it also with a fine brush. Don't destroy ever the connection. You know, the zirconia not sintered is not soft, so be gentle with this part. And then use always high qualified drills and cut out the connectors, and really make sure that you always clean this area after each step really nicely. And always in between, before you continue to work a lot of times on this zirconia prosthetic, please take a look under, especially after you cut it out. Please take a look and control the whole prosthetic under the microscope. Check if everything is milled perfectly, if there's no chipping or anything, if there's dirt or something. Please always control the connection during the process under the microscope. If there's anywhere a chipping, you have to repeat the work. Okay, for then to cut away the connectors. I mean, this is a state-of-the-art procedure. This is working with like any other prosthetic you do in zirconia. Use always new drills, don't heat it up too much, and be aware to protect with your fingers always the matrix connection. Yeah, always put your fingers above the matrix connection, so never a drill touch this connection, because this is the connection which goes later on into the implant. It has to be absolutely perfectly accurately done, so never do anything with your drilling instruments on this connection. If there's anything broken or something, or some dirt here, you can clean it, and you have to clean it before you go in the sinter oven. I recommend personally use the steam pressure to clean everything from any dust of zirconia before you go into the sinter oven. When you do that, you don't have to do too much pressure, especially on the connection and also on the screw seat, but make sure that all the dust and powder of the zirconia is gone away. And then please let these crowns or prosthesis or prosthetic then dry off. Leave it on the sides for a while, put it under the red light, just to let it dry off before you go in the sinter oven. This is important, because in the sinter oven we want to have only dry materials, and so please give it a time, but make sure that the connection is really nicely dried. Okay, sintering process. In the sintering process, make sure prosthetic is completely clean and dry. Control under the microscope before you go into the sinter oven. Make sure to exactly follow the instruction for use of the sinter process. And then in the sinter oven, place prosthetic central into the oven. Position matrix connection free and without contact to the oven. Do not use speed sintering programs if possible. So always check that the connection is not touching anywhere the walls of the sinter oven. Place it in the middle, and please read also the instruction for use from your zirconia supplier and also from your sintering oven supplier. Let the sinter matrix prosthetic slowly cooling down. Never shock it and cool it quickly down. Really leave it a time to cool down. This is important for the quality of the zirconia. Control prosthetic under the microscope on any chipping or micro crack. This is the important part when it comes out of the oven, when you continue to work on this prosthetic. Then always make a checkup look under the microscope. It has to look more or less before sintering like this. You see there's absolutely perfect rotational lock milled, and then after sintering, before sintering, after sintering, we have a perfect connection just coming out of the oven. This is how it has to look. Optical quality control, again, this is just a very important part. Please take a look at least with your glasses. Better is always to use a microscope if you are able to have a microscope, and then control things like this. Bad examples. You can see here the screw seat, inner screw seat. The machine was doing here, the tool was doing here some chipping. This is a no-go. You have to repeat the work in this moment. And on the right side, you can see here the drill was cutting a little bit too deep into the screw seat. This is a no-go. Repeat the work. This is also after sintering in the screw channel. A lot of powder, pressed powder of zirconia in the screw seat and so on. You cannot take this out by your drill, because then you destroy the fragile screw seat, which has to be really nicely milled. If you have area screw powder, or especially also maybe you do the glazing job as well. If there's glazing material on the screw seat or anything, also then you have to repeat the work. And here you can see a really bad milled connection, the matrix connection. This is not possible. The milling strategy was not working here, so this is a no-go. You have to repeat the work. This is how it has to look. You can see here, this is milled by the milling strategies. And here you can see that is just by STL fire milled, and there it's really nicely to see the difference and the high quality you can reach with in combination with the matrix milling strategies. So never mill matrix connections without having the perfect milling strategies in your CAM software implemented. The screw seat here, really sharp corners, a perfectly milled screw seat. This is how your matrix connection has to look after the milling process. The quality control afterwards is first by looking under the microscope, as already said, and then TRI also, as qualified milling certified matrix milling center, you have to have this quality control. This is the verification tool, and the verification tool is we have this verification tool created. It's for platform 4.5, or we have also the same tool for platform 3.7. You can see here a no-go side and a go side, and this no-go side is it's really between 20 micron. We have this side. This is showing you the screw channel. So if the crown is fitting on the no-go side like this, then you have to repeat the work, because we know the crown is created too big. If it's only a little bit of a gap, then control it on the go side, and if it fits on the go side perfectly, not like this, if it has a gap here, you have to repeat the work. It's too small. If it fits like this perfectly, then the work is perfectly done. You can watch here before you use this tool, before you get this tool, watch the video tutorial before using. This is explaining exactly, like on this table shown, exactly what is possible when it's a go as a crown, and when it's a no-go. This is an industrial tool which also TRI uses for titanium abutments before we send them to our customers. It's absolutely nicely to check every crown. You have to control every crown or every bridge work or any prosthetic you do with the matrix with this tool before you send the finalized prosthetic to the customer. And please make sure that any product is before you send it out is controlled by the verification tool of TRI. And don't forget to watch the tutorial. You will understand exactly how this tool works. Check the screw fit in the screw channel and fitting of the crown in the analog. So when you are working further than only milling, please after you controlled everything, just use the lap screws and check the fit. You can turn the screwdriver, the lap screws in here, and just feel the free movement of the matrix prosthetic. Here this is just an important part. If you control on the analog, take the screw. The screw will help you to centralize the crown into the position, and then move by hand. Here you see this is the rotational lock. A zoom into the rotation lock of the implant or of the analog, and this is the rotational lock of the prosthetic. Just stick the screw inside. Don't use forces, and gently turn just the prosthetic, and then it will fit perfectly into the implant analog, and then you can control the fitting on the implant analog as well. And don't force with the screwdriver in this stage. Just move everything by hand, easily, gentle into the connection, and then control everything if everything is really nicely working, and then you are ready to send the prosthetic to the customer. To finalize, respect the limitations of all equipment you use. Be aware of the limitations of your used equipment. read the instruction for use before you use, for example, the sintering oven and so on. Please use anything, every step like your supplier of your material is telling you. This is important, and if you do all these steps and be certificated, we at TRI promise you, you will have perfectly milled prosthetic, matrix prosthetic, like you can see it here. I think here pictures can show, can tell more than words. You can see here perfectly grounds milled with these so-called milling strategies on certificated milling laboratories. This is, I think, perfection just after sintering of matrix prosthetic. Thank you for listening. See you in the next part.